Hi, everyone. Thank you for joining us at the Microsoft Fabric UK user group. I'm your host, Leon Gordon, and I'm here with my co-host, Pragati Jain. Pragati, how are you doing today?
Hey everyone. I'm good. I'm good. Hope everyone else is doing well as well. How about you, Leon?
Yeah, absolutely fantastic. Thank you. It looks like we have Andy joining us from sunny Somerset. Perfect. Always glad to hear it's sunny. And also at least Rob joining us from sunny Scotland as well. So plenty of sun across the UK at the moment. Although for me personally, it looks like it's going to rain soon. I don't know about you, Pragati.
Yeah, same for me. I think I think it has already started to drizzle outside a bit, but I think that rain won't last. So we'll still have sun from tomorrow again.
Exactly, but it's well needed. It's well needed. But the weather
Yes.
aside, I'm so excited for today's session. It's going to be on real-time storm intelligence, and I don't think enough gets said about the real-time capabilities within Fabric. So really excited to go through our session today, Pragati. What about yourself?
I'm very excited for it. As we were talking backstage today, I was at Microsoft Reactive doing some lightning talks. And I went ahead and did a real time demo like in 4 minutes. So yeah, I'm quite excited for what our today's speaker is going to show us.
Fantastic. So let's go ahead and introduce today's speaker. So Navashri, thank you so much for joining us today.
Thank you so much for giving me opportunity, first of all, Leon. It's my pleasure to be here. So, yes, my name is Navashri Potluri. You can call me Shri. I work as Senior Solution Engineer at Microsoft. And today, in not so rainy England or UK, we're going to talk about how we're going to predict when a storm is coming. It's a bit tiny, but let's hope the rain is coming back to us soon, because I just read the news today in the morning and there are 63 fire incidents in UK. It's like, I don't want it. And the grass is not greener anywhere. Not on other side here. No, it's all golden. So I really wish rain to come in to start with. So I'm not really sure how many of our audience have already, looked into RTI capability within the Fabric. But in Fabric, as we always say, and most of you know, that it's a one unified platform. So let me just...
Yeah, let's go ahead and hand over to you and share your screen as well, Shri. There you go. Enjoy the session.
Thank you, Leon. Thank you, Pragati. So even before I go and talk about the use case, let me just give you a quick 2-minute intro of what Fabric is. So as I said, a Fabric is an end-to-end AI-enabled platform. It is governed, and if any of you has worked in data engineering hands-on like me, you would understand, getting a solution from end to end in any technology is at least 6 to 7 different products tying together. And then on one Monday morning, we come up and there is a keyword change, or a key or certificate has failed, and then the whole solution falls off. The best thing, or the thing that I love about Fabric, is it's being one solution, and you have 7 verticals in it: the data warehouse, databases, data science, RTI, and then a new feature called IQ, and then the Power BI. So everything in one lake, and you would be able to build all those things without any connections in between. And they have been integrated so well that we really do not worry about the security or the governance. And it is AI enabled at all stages. So what I would do is I would quickly give you an overall understanding of what this spell intelligence is. So I work in water industry to start with. So because of that, I use a lot of RTI in my day-to-day life. And rather than understanding how I use the technology, because I was very new to this industry, what I've started to look into is what are the issues that water industry is having. And when I see a water industry really, really stands on 3 things. One is regulatory, second one is assets, maintaining their assets, and the third one is customer experience. So the first one, regulatory, is the use case that I have taken. So what happens is, in the event of storms, when a sewage leaks into the river, it is polluting the environment, and it is polluting the water that we drink or that we use for every day. And the government and environment agencies have a regulation around it on how much you could release or how much spillage can happen into the water. And if you go beyond that threshold, you are fined for it. So what I have started thinking about it is, so how do I help them? Because, as you know, water industries are really regulatory, really very, very old technology. There are lots of assets everywhere, and they have loads of legacy databases, etc. So what I have done is this. I've taken Thames River as an example in our use case today. And then in this Thames River, what we would see is how we would be able to forecast when a storm would be coming in, and how we would be able to, score it, price it, how much it is costing to a company, and how we can act on it, not manually, but it's more like semi-autonomous, I would say. So the main goal of using Fabric RTI in most use cases is from being reactive to being proactive, from moving to a manual job to autonomous or semi-autonomous roles. So okay, now let's go to the next slide. As I said, a bit about me. I have 17 plus years across cloud, data engineering, analytics, and enterprise transformation. I specialize in Microsoft Fabric, Power BI, Copilot, and real-time intelligence. I am founder and host of AI Horizon, a community for a real-world generative AI and responsible innovation. I love mentoring women in tech because I want it to be technology to be a default choice for a woman, rather than anybody thinking about whether the tech is right for a woman or not. And I'm also a speaker and technical blogger, passionate about turning data into actionable, measurable business impact. If any of you want to join me or connect with me, there is a LinkedIn QR code, which I would be showing at the end of the session again. So, as I said, England storm overspills for roughly 3.6 million hours across 450,000 monitored events in 2024. This is a public record from the Environment Agency event, duration monitoring published in the spring. Off-VAT PR24 settlement allows about 104 billion sector investment across AMP8. AMP8 is 5-year cycle for the water industry, how they need to progress through those 5 years that comes from the regulatory companies. And then today the model is, as I said, reactive. We react on what already happened previously, not to predict and take preventive measures. And that is exactly what I'm trying to do, to move from reactive to proactive. So, as I said, the real-time intelligence flips the sequence from, forecasting the storm and then score the risk and act before the overflow even happens. So, 4 moves. Forecast the rainfall. What we're going to do in this demo is, and sewer conditions in real time. That might be the IoT sensors within the sewers. And then we would be doing a score on it based upon combining all the other data within the Fabric using Lakehouse and etc. And then we would price it to show how much we're going to cost, or company is going to cost, if it doesn't take that solution in. And then how we're going to act on it before the event happens. And this is how the flow looks like. So we would be ingesting with a data factory and the event land CSO, a rain gauge, sewer level and flow telemetry. These are all in the real time. However, for the demo purposes, I would be using synthetic data. As we all know, as I mentioned, we don't have too much rain in UK now. Even if I have a real connector for the weather within RTI, I wouldn't be able to get any rain forecast. So I'm using the synthetic data for that reason. And then store that data in Event House, keeps the live event history for fast time series queries, and then forecast it with using data science or notebooks. If you are a pro code, you would be doing some notebooks in there. And then we would be writing some functions from the analytics that we have got from here, and then score and price how much risk it is and how much it is costing to a company. And then we would act on it based upon a data activator, and then a real-time dashboard, which would show us the real-time data and how it is actually damaging a company or costing it, and what is the risk that they are involved at that point of time. So the forecast is not a decision, because what happens is it shows, for example, as I said, I'm only looking at the Thames River. So when you have all the different categories or catchments that you need to look for, it actually identifies and lets you tell what is at the higher risk at this point of time. Based upon these spilled risk, and at the risk how much it's going to cost to the company, what they would be able to do is the actions can be taken on those particular areas at that point, and then they really do not need to worry about, example, Reading, and they would continue to monitor Oxford, so they know where they have to focus, or their ground people on ground, and which needs the most attention. So we will be seeing that in the demo as well. So yes, let me switch my screens, and then I will show you the demo. Just give me a minute. Just give me a moment. I'm just trying to. Okay, so this is the real-time dashboard that I have created for Thames, and I'm calling it as a spill intelligence. Please don't be bombarded with the numbers. This is all synthetic. As I said, because we don't have too much rain, I'm trying to bring the solution to the live.
Sorry to jump in. We're still seeing your Azure portal screen at the moment with the fabric capacity.
Okay, let me quickly see why that is happening.
Yeah, no problem at all.
Okay, that might be because I might be sharing that particular screen. Share screen. Are you able to see this now? The spill intelligence?
Yes,
Yes,
now
we can indeed. Perfect.
Okay.
Thank you.
Wonderful. Thanks, Leon. You did not tell me halfway through. I would have repeated everything again. But thank you so much for catching it early. So, as I said, this is a Thames Spill Intelligence real-time dashboard. And because it's a demo purposes, I have not activated it to run every second. But what you can do is you can go to the list of 5 seconds. So every 5 seconds, this dashboard keeps on running on your data, and then it would pull the data automatically onto the dashboard. So what I'm showing you as I said, is how much it is going to cost a company, and what is the 24-hour spill cost is looking like, how many active spills do we have, and how much is it costing by different catchments. And then it also shows us the CSO risk map, and then the live spill risk board, and then how is the actual versus forecast is looking like, and the spill cost trend, etc. So even this is the solution, or this is the end solution that we're going to get. But I'm going to go and show you how I have created all this from end to end. Even before I do that, let me quickly show you this. So as I said, I didn't use any synthetic data, but I do have event stream, which is using a synthetic, like a proper weather connector within real-time intelligence. So if you could see in here, I am pulling the location, and this is the source connector that we have readily available in real-time intelligence. So if you click on connect data sources, here we do have the real-time weather. And then when you connect it, you give the location or the anything that you have. And then once you select it, that is DB. Once you select it, it would point out where that address is. And when you click next, that is where it would give you a point. And so this is a real-time weather connector, which gets the information about the weather, how is the precipitation, or how is the humid looking like, is there a rainfall forecast, etc. And then it also continuously refreshes. It is live. But the reason that I'm not using it is like we won't get any rain using this. So what I've done is I've created another event stream, which is using synthetic data. So let me quickly show you the other synthetic data that I have, which is operations efficiency. And what it does is it is trying to, no, it's not operations efficiency, sorry. Yeah, weather storm overflow synthetic generator. So what it is trying to do is like it's a custom endpoint that I am connecting it to. And this custom endpoint is coming from a notebook. So in this notebook, what I'm trying to do is I'm trying to create a synthetic data for weather raw, overflow raw, and water quality. And then I've created some catchments around the themes. And then I am asking it to send me the rainfall, how the storm level would be if the rainfall is greater than 18 mm or 8 mm or 2 mm. And then I'm creating the synthetic generator. So this usually, the weather especially, we usually get it from a native connector, which I've already shown. But because I need to bring the solution to the live, that is what I'm doing. And then I've created some for the water quality. These would be coming from the sensors in the river, as well as we would be getting some readings from sewages as well, using the IoT devices or MQTT solutions that we have within the water industry. So when I run this, it is running at the moment. When I've run this, it is giving the water quality, weather, overflow, and all this tables information, as I said. And then you could actually see what all we have in here. So the data is looking like this. So we do have the forecast data coming, and then overflow and etc. So if you want to see one of the tables, so what I'm doing is like, because I'm just getting from one synthetic data, I'm just pushing the data into one table, and then I've created all the mappings and etc. from there. So if you could see the data, we do have 99,000 records. And then I can summarize it with event type, which is like all these tables that have synthesized to it. And then I do have some functions as well, which I've created, which would calculate the telemetries of it, the health of it, the water quality, and etc. I was thinking, yes, I need to have, so the weather catchments, and then overflow events, final overflow visuals, spring, forwards, and synthetic. These are all the functions that I have created as part of, the functions as we know. It is a part of a logic which we can pull when we are trying to create real-time dashboards, or the logic that we can use, keep on using. So these are the things that I have created. So when I've done this, the next one is what I've done is I have connected in the notebook to the outside, or to the data that we get it. So I'm pulling the data from flood monitoring, where we would get the data on an hourly basis, and it would predict whether a flood is about to happen or not, and then the water quality observation, and then meteor. But we would have some different data sources, or MQTT P6 sources within the company, from where we would be able to get part of this data. The other important thing that I wanted to showcase was, so when we create this data synthetically, or when we get this from the IoT devices, how they come in is they come in as a pipe 1, 2, 3 is having a pressure of 4, 5, 6, but we don't know what pipe 1, 2, 3 is. So what I usually do is I connect that to my lake houses as well, which would give me the context. But again, in the demo purposes, lake house is where I'm giving the context. But if it is not the demo purposes, we would be getting it from a database, master data management, or a fact table, or a dimension table, all this information where we can connect it within the KQL and then get the data out of it. We can create the dashboards from staying within the KQL dashboards, or we can just go here and then create a new item and then go and create a real-time dashboard. That is what I've done. And then when we go to the real-time dashboard, another thing that we would be doing is we can add an alert. It's like, if you think the active spills should not be above 80, you would create a spill. You would create an alert on it, telling that on each event, it is a numeric stage. It is greater than, let's say, 75. Then what I need you to do is, I want you to send me a Teams message or an email, or run different Fabric activities, or create a custom action, which is more like you would be able to connect to the Power queries as well, the Power automate flows. So for this case, I am going to send it to an individual, which is like myself, and then I would keep it. And then why is it not? Okay, I need to give a name. So test alert, and then run the query. For now, I'm putting it as a minute. Active spills is greater than 75, and we have given all the other things, and then create. And once it is created, it shows that there is already an active spills, which have given an alert of 70 maybe, but now I've created a test alert here. Now, if I go to my Teams, are you able to see my Teams, by the way?
No, we're not currently. We're still on your Fabric screen at the moment.
Yeah, I thought so. I just wanted to check. Let me quickly go back and then.
Maybe you can share the window, Shri, if that's easier, so you can have all the applications that you want to show on the same window, basically on your one machine.
Let me quickly see that. I did share my screen window, but it is entire screen.
Okay.
Okay, let me share the entire screen, because when I'm doing that, are you able to see my?
Yes, we can see your teams. Yeah.
So when I have raised alert in here, it keeps on running every time. And as I showed you, it is running every 5 minutes or every minute. And then please don't do that. Please don't send 1 minute, you'll go mad, because it keeps on sending you the alerts every minute telling that, you know, it has gone a threshold value, and you can actually customize it, the body as well. And then it would tell which rule in the activator has alerted this or activated it, because as you could see, I have 2 alerts. So it would tell me which one has triggered, and then we can name it. So activator alert is what is going on at the moment. So this is the activator alert. And then I keep on getting the data. I have been running the solution for half an hour to 1 hour now, just to show you and give the feel of it. So it keeps on sending me, these things. So the best thing about it is the IT people who needs to work on these solutions, that really do not need to come into your Fabric environment to know that there is an issue happening. So you can send them via an email, or with the help of, or the next step that I'm thinking of doing or haven't done yet, to be honest, is to create a Fabric app. So you can create a Fabric app and you can invoke that, by, do something else. And then you would be able to, or the IT system people would be able to see the message in their apps telling that something has gone wrong and I have to dispatch to that location to understand or to control the situation. So these are all the different things that we can do within the Fabric. And then one other last thing is, one other question that I keep getting is, when do we use a real-time dashboard and when do we use a Power BI? I would say when you are actually working on a data which is constantly moving as this, I would suggest using a real-time dashboard, because the real-time intelligence has been created on the platform, the Custo query language, and then the data is in Delta Parquet format. So it is designed for speed. It will handle a lot of data, so at ease. So when you're having too much of data coming onto your platform, and then you want a platform where you could actually keep a check on the KPIs and then work on it, then the real-time solutions or real-time intelligence is what is you need. But if it is for a KPI, you want to be a bit more exploratory, see what is happening, then you would switch to the Power BI. So I would say that it would be more for the main issues that you want to check and keep track of. That is where the real-time intelligence comes in. So let me go back to my PPTs. Give me a minute. So as I said, we would identify, I did not show you this, so I can actually go back and show you some of the queries that I have. So where is that? Build intelligence. So KQL query sets are the query sets on which we would write KQL queries. And also KQL queries are very close to SQL. If you don't know, we always have the Copilot to ask how to write a KQL query. So we do have that facility as well. So as I showed you, this is the synthetic data that we are running, and this is how we would see the spill cost at risk now. It shows what is the rainfall, what is predicted, and by when we are expecting a spill to happen, and how much risk is it going to cost a company. So with that information, as I said, we would be able to put the ground people onto the incidents that are really critical and important and costing money and fame to the water industries, rather than just going everywhere where the incidents are happening, because the high impacted incidents need to be taken care first, and then we would continue to monitor the other ones. So the forecast synthetic is more like it shows you, based on the telemetry data that we're getting from the sewers, and then based upon the river quality, water quality sensors, and combining with that with the weather data, we would be able to forecast when a spill can happen and how much damage, which catchment it is going to do, which site it is, and then where it is located, and what is the forecast rain looking like. So once the incident happens, we could also actually store that data and see how the forecast is, how much closer the forecast is to the reality. And if it is too far away, then we would be able to understand where the issues are. I keep on getting the fabric activators. Maybe I need to just take them off. Where are they? I'll deal with it, that's fine. So these are all the different things that you can do. If you ask me what is that I need to learn from this demo, technology is, everybody can get hang of technology when you keep on working on it. So what I would ask you to do is to identify what those use cases may be, to identify a signal where we could use a real-time intelligence. So real-time intelligence do not only tell you that it's IoT data. It can be audits, it can be log files, it can be something which is generating data. So when you find, or when you understand what those signals look like, what happens is you would be able to start formulating a issue around it, what the problem is. Because in most of the scenarios, what I have seen is especially with RTR data, the log data or the audit data, nobody looks into it. They just are left alone in a corner, and the data is just piling up and nobody knows how to use it. And I think this is the best tool where you could use the real-time intelligence and start analyzing those data, and also perform the data science based upon the history of that data. And that would give you a solid solution to start with. So as I said, what we have done in the event, in the demo, is turn every storm into a priced preventable event. We were able to integrate the data. We know that the Fabric has a capability of connecting to the real weather data or the APIs with the custom APIs. And it is also having many native connectors, and it is still going on and on. So I would ask you to go ahead, check the different connectors that we're having in RTI, and then start working on it. And at any point, if you have any questions, I think Leon, Pragati, or me, we are equally capable of helping you guys on how we can take it forward. 1 second. Okay, I think I will stop the screen and then present. So yeah, I am almost into the session. I've already shared what I can. So if you have any questions, I'm happy to take them now, and then we can take it from there.
Fantastic. Thank you so much, Sri. We do have, if I'm not mistaken, Pragati, would you like to go ahead and ask this question?
Yeah. Yeah, we do have one question from Elizama Heather. Sorry if I'm mispronouncing your name. So she's asking, so this is related to the starting of the session, Shri, when you were talking about handling millions of events. So the question is, if you were designing the solution for a production environment handling millions of events per day, what architectural changes would you make to ensure scalability, fault tolerance, and cost efficiency?
Um, yes. So yes, if I am doing it for a production environment, handling millions of data, just a fun fact, we handle petabytes of data every day on RTI solutions platform. So it is very capable of handling millions and millions of events. And just to add another point to it is I hear from customers that RTI is a very new tool. It's like that is a myth because RTI has been developed based on the Azure Data Explorer, which has been in the market for over a decade. And before that, the Azure Data Explorer was created to handle the audits logs of Microsoft. So I really do not need to add any more to that because, as you know, Microsoft is a global company with thousands of people, and it itself can produce huge amount of data. And we have worked on ADX, and then we've released it, and that ADX has been in the market for 10 years, and now we have moved that into Fabric as a real-time intelligence. So I think my point is noted, and it is done there that there's no doubt that real-time intelligence cannot handle a data because it is already handling loads of data for years. What architectural changes would you have been doing here? I would have, because the events have late events or they are not synchronous, they might be coming here and there. We need to put in late events handling. Are you going to have a minute window after an event happens? You will wait until a minute or a half a minute, 30 seconds to have that event, or do you really do not want that event? You would just drop it off. So it all depends upon the different conditions that you want to go ahead with, and that I would be doing it in the production to make sure that I have the fault tolerance as well to handle the late coming events. And the cost efficiency, I would say the cost efficiency is more like, now, as you know, that Fabric is on a capacity. And when I'm paying for Fabric capacity, I'm not only using the real-time intelligence, but also using the one leg, the Power BI, the real-time dashboards, the data factory, data warehouses, data sciences. So I would make sure that whatever capacity I'm getting, I am utilizing it for until 80%, and then use the bursting and smoothing technologies to handle my whole capacity, and that is how I would be cost efficient.
Yeah. Thank you so much, Shri.
Fantastic. Thank you so much. It seems like that's the only question we have coming in at the moment. So I want to say absolutely fantastic session there, Shri. Quite timely as well, as we pretty much just had some rain where I am. So the beginnings of that storm, I could have done with some activator alerting coming in, to be quite honest with you. And yeah, it's for me, it's fantastic to see how far RTI has come. So kudos to both yourself and obviously the product team at Microsoft to keep working on all of these fantastic solutions for us.
Yeah, I can't stop talking about RTI. If you give me, a day, I will keep on talking. But again, there are other technologies which are really, really, really interesting. Like if anybody are interested, please go and start looking at what Microsoft IQ can do. It's like straight, this is like bonkers. And it's like it really shows us that we are already in that AI future cinematic Hollywood movies. And it's like I could feel that we are already there. I could see that our future is going there with this technology. So just have one suggestion I would ask you all to do is like activate your free trials and then start getting your hands dirty. And I'm pretty sure you will be creating more demos than I have created, more wonderful, more meaningful. but hopefully you understand, I made some sense in the demo. But if anybody have any questions, as I said, Leon, Pragati, or me, we're equally capable of supporting you guys. So just give us a shout.
Amazing. Thank you so much. And we've also shared your social media details as well, so please do feel free to connect with Shri. And Shri, we'd love to have you back with us again in the future as well, when time allows.
Oh yes, definitely. As soon as I have more demos, I would be like, Leon, where am I getting to?
Oh, we would love to have you, Shri. This was
you.
an amazing session.
Thank you.
Okay, Shri. Well, thank you very much. We'll go ahead and close out today's session. So just want to thank you all for joining us today. You could have been anywhere in the world, but you've been here with us at the Microsoft Fabric UK user group. And thank you again, Pragati, as well.
Thanks everyone. It was an amazing session, and yeah, watch out. We have got so much coming in next few weeks. Yeah, we have got few things in lineup, and yeah, of course, we are going to bring more content to you. And yeah, don't forget to fill the feedback form that we have just put in the link, because that's really important for us to understand what kind of content you guys are looking for as well. So definitely fill that, and yeah, stay tuned. We'll definitely bring something more exciting for you guys.